Okay, so good morning, afternoon, or evening, wherever you are based, guys. My name is Partha Samal, and today I'll be discussing the transformative power of ambient intelligence and its potential to enhance our everyday environments. So let's get started. Before diving into the topic, let me share a bit about myself. I have over 20 years of experience in the software industry, and I'm currently working at Paramount in the media and entertainment sector. My experience has given me insights into various technological advancements, including ambient intelligence. You can also connect with me on LinkedIn for more professional updates. Feel free to reach out if you have any questions or collaboration ideas. What is ambient intelligence or AMI? Ambient intelligence refers to the integration of technology into our daily environments to create intelligent, responsive spaces. It is about making our surroundings capable of understanding and reacting to our needs, making our lives more convenient, efficient, and enjoyable. Let's break down the key characteristics of AMI. Context awareness. This means the technology can sense and understand its environment. For example, a smart thermostat can detect the room's temperature and adjust it to your preferred setting. It knows whether you are home or away and changes the settings accordingly to save energy. Personalization. Personalization involves tailoring the technology to fit individual preferences. Imagine your music system playing your favorite songs when you enter your room, or your lighting getting adjusted to perfect brightness for reading when you sit down with a book. This customization enhances the user experience significantly. Adaptability. Adaptability means the system can change and improve over time based on the user behavior. For example, a fitness app might adjust your workout plan and you get fitter, or a smart fridge might reorder groceries based on your consumption pattern. These characteristics work together to create environments that are not just smart but truly intelligent, capable of learning from and adapting to the users within them. Imagine a home that knows your schedule and adjusts the heating, lighting, and even starts brewing your coffee as you wake up. Or a city that manages traffic in real time to reduce congestion and pollution. This is the potential of ambient intelligence. Let's explore the core technologies that make ambient intelligence possible. Sensing and data collection. So this involves using various sensors to gather data from the environment. Examples include motion detectors that sense movement, cameras that capture the images, microphones that pick up sound, and biometric sensors that monitor physiological data like heart rate and body temperature. These sensors provide raw data that is essential for making intelligent decisions. Data processing and analysis. Machine learning. So this technology helps in recognizing patterns and making predictions based on the data collected. For example, machine learning algorithms can analyze energy consumption patterns in your home to predict when you are likely to be home and adjust the heating or cooling systems accordingly. Natural language processing or NLP. NLP enables systems to understand and process human languages, making interactions with technology more natural. Voice assistants like Alexa, Siri, and Google Assistant use NLP to understand your commands and respond appropriately. Computer vision. So computer vision technology interprets visual information from the environment. It can be used for facial recognition, object detection, and scene analysis. For example, a security camera with a computer vision can recognize familiar faces and alert you to any unknown visitors. Communication networks. Wireless networks. Technologies like Wi-Fi and Bluetooth allow devices to communicate with each other wirelessly. This connectivity is crucial for seamless operation of smart devices. Internet of Things or IoT. IoT refers to the network of interconnected devices that can communicate and exchange data. For example, your smart fridge can notify your smartphone when you are out of milk, and your smart thermostat can be controlled remotely via an app on your phone. So these technologies work together to create intelligent systems that can sense, analyze, and act on information from their surroundings. For example, in a smart home, sensors collect data about the environment and occupants' behavior. Machine learning algorithms analyze this data to identify the patterns, and the system adjusts the heating, lighting, and other parameters accordingly to optimize comfort and efficiency. Ambient intelligence can be applied in many areas, transforming how we interact with technology in our daily lives. Let's look at some core applications of AMI. Smart homes. Smart homes use technology to automate and personalize various aspects of living, such as lighting, heating, security, and entertainment. For example, a smart thermostat learns your temperature preferences and adjusts the heating or cooling accordingly. Smart lighting systems can adjust the brightness and color of lights based on the time of the day and your activities. Likewise, security systems can include smart locks, cameras, and alarm systems that you can control remotely from your smartphones. Healthcare. So in healthcare, AMI enables remote patient monitoring, providing real-time data and alert systems. For example, wearable devices can monitor vital signs like heart rate, blood pressure, and blood sugar levels and send this data to healthcare providers in real time. This can improve patient care by allowing healthcare providers to monitor patients continuously and respond to emergencies quickly. Smart medication dispensers can remind patients to take their medication and alert caregivers if a dose is missed. Smart cities. So smart cities use AMI to optimize traffic management, enhance public safety, and conserve energy. For instance, intelligent traffic lights can adjust their timings based on real-time traffic conditions to reduce congestion. Smart street lights can adjust their brightness based on the presence of pedestrians or vehicles, saving energy. Public safety systems can include surveillance cameras with facial recognition and predictive analytics to identify potential security threats. Retail. In retail, AMI enhances the customer experience by offering personalized recommendations and intelligent inventory management. For example, smart shelves can track stock levels and automatically reorder products when they run low. Beacon technology can send personalized offers and promotions to customers' smartphones as they walk through the store. Self-checkout systems can use computer vision to identify items and facilitate faster transaction checkout. Automotive. AMI is also transforming the automotive industry by developing smarter and safer driving environments. Features like adaptive cruise control, lane keeping assistant, and automatic energy braking are examples of how AMI can enhance driving safety and convenience. Autonomous vehicles use sensors, machine learning, and computer vision to navigate roads, avoid obstacles, and make driving decisions. In-car personal assistants can provide navigation, entertainment, and connectivity features. These applications demonstrate how ambient intelligence can significantly improve our daily lives by making environments more responsive, efficient, and personalized. So this slide shows a flowchart summarizing the core technologies we have discussed. It illustrates how sensing and data collecting can help in data processing and analysis, which then informs the action taken by the system. Communication networks connect these components, enabling seamless interaction between them. Sensing and data collection. So the process starts here with sensors collecting data from environments, data processing and analysis. So this data is then processed using machine learning, NLP, and computer vision techniques. We have communication networks, which is like wireless networks and IoT, which ensure all these components can communicate and work together. And based on all this analysis, the system takes action, such as adjusting the temperature, sending alerts, or providing recommendation. So this flowchart helps visualize how different technologies integrate to create an intelligent and responsive environment. Let's take a closer look at how data processing and analysis work in ambient intelligence. As I said, machine learning. So it involves creating models that can predict outcomes based on input. So for example, a simple linear regression model can predict energy usage based on the past consumption data. The model might be represented by formula y equal to mx plus b, where y is the predicted energy usage, m is the slope of the line, and x is the input data. Example, temperature, and b is the intercept. More complex models can analyze multiple variables and identify intricate patterns. NLP, or natural language processing. It involves several steps to understand and process human language. We have tokenizations, breaking down the text into individual words or tokens. Then we have stemming, reducing the word to their root forms. For example, running, skipping, it becomes run or skip, right? Parsing, analyzing the grammatical structure of sentences to understand the relationships between words. This allows systems to understand and generate human language, making interactions more natural. For instance, when you ask a voice assistant to set a reminder, NLP enables it to understand your request and respond appropriately. We must have felt that using Siri or Alexa. Computer vision. So computer vision processes visual data through several steps. Feature detection, identifying the key features in an image, such as edges, corners, and textures. Then it recognizes recognition based on the matching of the features to know patterns or objects. For example, facial recognition systems analyze facial features to identify individuals. So this technology can be used for various applications, such as recognizing faces in security systems, detecting objects in autonomous vehicles, and analyzing images in healthcare. So these technologies enable AMI systems to make sense of complex data and make intelligent decisions. For example, in a smart home, machine learning algorithms can predict when you are likely to arrive at home and start hitting the food in advance, or maybe start hitting the house in advance. NLP allows you to control your smart devices using voice commands and computer vision. It can enhance security by recognizing familiar faces and alerting you to any unknown visitors. While ambient intelligence offers many benefits, there are several challenges to its implementation. First and foremost is privacy and security. So protecting user data is crucial. This involves using encryption to secure data. Encryption transforms the readable data into a coded form that can only be accessed by someone with the correct key. For example, an encryption formula, as we all know, C equal to E K P, where C is the ciphertext and K is the key, P is the plain text, and E is the encryption method. So strong encryption methods ensure that even if the data is intercepted, it cannot be read without a decryption key. Additionally, robust access controls are necessary to ensure that only authorized individuals can access sensitive data. This includes defining the user roles and permissions, regularly updating the security protocols, and conducting security audits. Interoperability. So different devices and systems need to work together seamlessly. This requires common standards for communication. An interoperability system might look like device A communicates with common standard and device B also communicates with the common standard. So by adhering to the common standards, devices from different manufacturers can communicate and work together effectively. For example, with smart home systems, we should be able to integrate devices from various brands, allowing our smart thermostat, lighting system, and security cameras to be integrated and work in harmony. Developing open protocols and standards is essential for achieving this level of interoperability. Last but not the least, user acceptance. So users need to trust and feel comfortable with the technology. This involves designing intuitive user interfaces that provide a positive experience. A user interface design might be represented as communicates with the intuitive UI and provides and he gets a positive experience. So ensuring that the interfaces are easy to navigate and understand is crucial for a user acceptance. For example, a smart home app should have user-friendly design that allows users to control their devices with ease. Providing clear instructions, offering customized options, and ensuring data privacy can help build trust and encourage user adoption. Addressing these challenges is crucial for the successful implementation of AMI. Ensuring robust privacy and security measures, achieving interoperability, and designing user-friendly interfaces will help overcome these obstacles and pave the way for widespread adoption of ambient intelligence. In future, we need to focus on several key areas to advance ambient intelligence. First one is like enhanced privacy and security measures. So implementing role-based access control to ensure that only authorized users can access sensitive data. For example, different levels of access can be given to different users on their role. Example, permission equal to role based on the user, where an admin has full access, a guest has limited access, and likewise, whichever user we want to give differential access, we can definitely give that. Additionally, continuous monitoring and regular updates to security protocols are essential to protect against any new threats or threats which can disrupt the system. Educating users about security best practices can also help enhance the overall security. Improved interoperability. So developing modular architectures that allow different modules to work together seamlessly. This can be represented as module 1 plus module 2 works together to perform as an integrated system. So modular designs enable easy integration and upgrades, allowing systems to evolve without major overhauls. For instance, a modular smart home system allows users to add new devices and functionalities as needed, ensuring compatibility and smooth operation. Standardizing communication protocols and fostering collaboration between manufacturers can further improve interoperability. Greater user acceptance. So ensuring transparency in data usage to build user trust. So this involves clear communication about how data is collected and used. A transparency model might look like data collection, then it is connected to provides clear communication, then it ultimately builds user trust. So providing users with control over their data and explaining the benefits can help build trust. For example, informing users about how their data helps improve their experience, offering opt-in and opt-out options, and ensuring compliance with data protection regulations can enhance user acceptance. Research and development. So continued innovation through collaboration between research teams and industry experts. So this involves working together to come up with new ideas and solution. A collaboration model might be represented, like a research team is working with industry experts to provide innovation. Innovation could be in any form, but just to provide a different perspective and innovation, we use the research team as well as industry experts. So in conclusion, ambient intelligence is set to revolutionize how we interact with our environments by addressing privacy, security, and interoperability challenges and promoting user acceptance through intuitive and transparent practices. We can harness the full potential of this technology. Future advancements will depend on continuous research and collaboration, and the future growth with AI, ML, and what the world has in store. So the journey towards fully realizing ambient intelligence is ongoing and developing, improving as I'm talking here, and we are all just beginning to explore its possibilities.